Hello everybody, myself Prashanto Mukhopadhyay, faculty member, Electrical Engineering Department, Greater Kolkata College of Engineering and Management. Today in machine class, electric machine 2, so we'll start a new topic, methods of starting, braking and speed control for induction motors. So first of all, we'll discussion will be started with the methods of starting. So basically, we first have to know why we need a starter, okay, and then what are the different types of starters we have. Then we'll discuss about the different types of starter one after another. So let us start with the necessity of a starter in a three-phase induction motor. So basically, three-phase induction motors are self-starting due to rotating magnetic field. But the motors have a tendency to draw very high current at the time of starting. And such a current can be 5 to 8 times the rated current and can damage the motor winding. So a starter is used which can limit such high starting current. So it is clear that during starting, though it is a self-starting motor, the three-phase induction motor, because it has when the supply we are providing at the starter, a rotating magnetic field will be created, and we know as per the principle of working of the three-phase induction motor, so motor will start to rotate. But during starting, motors have a tendency to draw a very high current. It is about 5 to 8 times more than its rated current, and due to this, though it is momentary, so this due to this high current, motor winding can be damaged. So there is a necessity to limit this high starting current, and that's why we use a starter. So in a three-phase induction motor, the magnitude of an induced EMF in the rotor circuit depends on the slip of the induction motor, as we have seen earlier in our discussions of the EMF, induced EMF and current of the rotor side when we have discussed. So this induced EMF effectively decides the magnitude of the rotor current, and rotor current in the running condition can be given as if this is I2R is the rotor current, so it will be S E2 by root over of R2 square plus S X2 whole square. So that is, this is the rotor induced EMF, and it is the rotor side impedance at slip S, and this is the rotor induced EMF at slip S. So this is the rotor current. We have discussed this in our earlier discussion. Now at start, the speed of the motor is 0 because at start motor speed is 0 and slip is at its maximum. That is maximum means unity, and so the magnitude of the rotor induced EMF is very large at the starting, and as rotor conductors are short-circuited, this large induced EMF circulates very high current to the rotor at starting. Clear? So actually at starting, rotor speed is 0 and unity is it is at unity power factor is very slip, and the magnitude of rotor induced EMF is very large at starting, and so rotor currents, rotor conductors in as it is short-circuited, so large induced EMF circulates a very high current to the rotor at start. So in a three-phase induction motor, when the rotor current is high, the starter draws a very high current from the supply, and this current, as I told you earlier from the very beginning of this discussion, that this current should be maybe of the order of 5 to 8 times the full load current at starting. So due to such heavy inrush of current at starting, there is a possibility of damage of the motor winding, I told you, and it may cause this large line voltage drop. So because this high current as say it may cause a very large line voltage drop, and as a result, so other appliances connected to the same line may be subjected to voltage spikes which may affect their working. So not only due to it is not only harmful for the induction motor itself, but due to a large line voltage drop, the other appliances or say equipments connected to the same line may be subjected to a very voltage spikes which may affect their working. So to avoid such effects, it is necessary to limit the current drawn by the motor at start, and the starter is a device which is basically used to limit high starting current by supplying reduced voltage to the motor at the time of starting, and such a reduced voltage is applied only for short period, and once the rotor gets accelerated, a full normal rated voltage is applied. Okay, so we can very well understand why the starter is necessary, because as I told you, so at the very starting, say motor draws a very high current which is say of the order of 5 to 8 times its rated current, and as a result it may cause the damage of motor windings, or there will be since the rotor conductors are short circuited, so due to this circulating current line voltage will be dropped, say, and due to this voltage drop the other appliances or equipment connected in the same line will their functioning, their working will also be affected due to a voltage spike. And so to avoid such effects, and it is necessary to limit the current drawn by the motor at start, and that's why starter is basically used to limit this high starting current by supplying how it will be limit, or how this high starting current will be limited. So this will be limited, or it will be limited by this reducing the starting current, and that can be reduced by supplying reduced voltage to the motor at the time of starting. So such a reduced voltage is applied for a short period, and once the rotor gets accelerated, full normal rated voltage is applied. So then from these discussions we can conclude then what should be the functions of the starter. If we say just arrange our discussions in this fashion, so we'll find that functions of a starter will be or it will limit the starting current, provides the protection against overloading, provides the protection against low voltage situations, and also provides protection against single phase. So not only it limits the starting current, it also provides protection against overloading, protection against low voltage situations, and also protection against single phasing. So that is in a nutshell the function of starter, and why starter is used, what is its function. So we have discussed. Now first of all we start with a starter which is known as the DOL starter, or sometimes called DOL starter, or basically it is a direct online starter. So D for direct, O for on, and L for line. So this is direct online starter. So from this DOL starter name is being generated. So basically if large rating induction motors are connected directly to the supply, heavy starting current can damage the motor and also cause disturbance of the voltage, and that is voltage dip on the mains supply we have discussed, and this can lead to malfunctions of other equipments connected to the same supply, and thus dual starters are limited to small rating motors where distribution systems, that is main supply, can withstand high starting currents without excessive voltage dips. So dual starter consists of MCCB, miniature say molded case circuit breaker, MCCB, contactor, and overload relay. So it acts as a switch under normal working conditions by providing the means to switch on and switch off the motor. So as I told you, so it's consists of MCCB, contactor, and overload relay, and acts as a switch under normal working conditions, and by providing the means to switch on and switch off the motor. So okay, so now we can discuss what are the construction or parts of dual starters. So basically it consists of two push buttons. One is a green button for starting the motor, and other is red for stopping the motor. That is green for on switch on purpose and stopping purpose. So red for switch off purpose. So switching of power supply is carried through an electromagnetic contactor, which can be 3 or 4 contactors. This electromagnetic contactor has 3 normally open or inner contacts that connect the motor to the supply line, while a 4th contact, also called as an auxiliary contact or control contact, works as an hold-on contact when the start button is released in order to energize the contactor coil, or that is the no-hold coil of the contactor. So this auxiliary contact, that is NO or NC, makes the contactor to be electrically latched while the motor is operating, and these contacts are less power rated than 3 main NO contacts, which are the power contactor, which are the contacts are connected in the power supply. So that is power circuit. So, and this contacts it is for say control circuit. So if any reason the power supply fails or voltage drops excessively, it releases the latch by de-energizing the coil. The coil means this no-hold coil, and thus the motor disconnected from the supply. Okay, so this is about the contactors, which having 3 or 4 poles, 3 poles for power supply, and basically these are the NO contacts, and a 4th one is the say auxiliary contact, which is used for control purpose, and or hold-on contact when the start button is released in order to energize the contactor coil. And the auxiliary contact, or whether it is NO or NC, makes the contactor can be electrically latched while the motor is operating, and these contacts are less power rated than 3 main NO contacts. And if any reason the power supply fails or voltage drops excessively, it releases the latch by energizing the coil, and thus motor disconnected from the supply. So let us discuss about this components of the dual starter. This is a dual starter. So these are the main terminals. This is 1, 3, and 5 main pole terminals. So main pole terminal 1, 3, 5, and say 2, 4, 6. Okay. Now this is auxiliary contact terminals 1, 3, and this is auxiliary contact terminal 1, 4. This is actually no-hold coil. Okay, so these are the no-hold coils terminals A1 and A2. Okay, so this is the airbag contactors, and this is the coil, and this is the coil and coil contacts A1 and A2, and these are the main poles contact. It is 1, 2, 5, 2, 4, 6. That is 1, 3, 5, and 2, 4, 6. That is 1, 2, 3, 4, 5, 6. Okay, and this is auxiliary contact 13 and 14. Okay, so when coil is energized, it becomes a magnet pole contact closes, and auxiliary contacts also closes. So this is actually, if it is energized, so it will this will close this all these contacts. Okay, so this is the main components of dual starter, and these are the contacts. Clear? So actually, this is your noble coil, and this is the main force contact, and this is auxiliary contact. And when it is energized, so these contacts will be connected, as I told you. So contactor coil is connected in series with start button, stop button, and overload trip mechanism. And this connection is called the control circuit, which is generally energized. That is, this A1 and A2 terminal is connected with from the two lines of the three-phase supply via a step-down transformer. Okay. Now we'll talk about overload protection. Basically, this is required with a dual starter. It's provided with a overload relay to protect the motor from overloads. So the overload relays are provided with heating elements inside of which bimetallic strips are arranged. When excessive current flows to the motor, overheating causes damage to the motor winding. The overload coil becomes hot when the overcurrent flows to the motor, and this causes the bimetallic strip to expand, and thereby opens the trip contact. Okay, so if we say, see, this is the overload unit. This is thermal type unit. Basically, see, this is like, these are the main terminals which is connected to the airbag contact. That is, it is connected here. If it is here, so it is pushed here. That is 2, 4, 6 with. Okay, now or if it is or 135 main port terminals, actually this is connected to not here, this is not connected to here, so 135 main terminals, and this is also the main port terminals, actually 246. Okay, so basically and these are the normally closed auxiliary contacts. 95, 96, that is shown here. This is normally closed, and this is normally open auxiliary contact. 97 and 98 if it is required. Somewhere it is required closed contact, or somewhere it is required normally open contact. So auxiliary contacts are also latch open, and when interlocked within a control circuit prevents motor restarting by itself and cool. And here is a reset button. So this red push button can be used to reset. And this is the current setting point. You can set the overload current. So this overload mechanism should operate at 20 to 30% of overload. And when the overload coil strips, the current through contactor coil stops flowing, and hence the contactor contacts come to the off position, and overload relays are provided with a current adjuster that I told you. So this is the current adjusters. So such that the tripping coil current can be adjusted depending on the load protection requirement. Okay, so that's all about this is the overload thermal type overload details of the thermal type overload unit. Okay, now we'll discuss the working of dual starter. So actually, the wiring of a dual starter will start and with start and stop button that is shown in the figure below, and the dual starter main terminals are connected between the main supply terminals and the motor terminals, and while the control circuit is energized with two terminals of the three-phase supply stored. So this is the main terminals. This is connected with this is the supply, and this is the supply. Okay, and this is connected with through overload. That is connected with the terminals of the starter winding of the AC motor. So this is three-phase supply. Okay, and this is the motor contacts, power supply contacts, and through overload, as I told you, this is connected to the say motor starter winding. Okay, that is the motor terminals. Okay, and see when this is the contactor coil. If it is energized through this R and your another supply, that means it is with this. Okay, stop. So this is another coil is it is supplied. Contactor coil is supplied like this. Okay, start. Yeah, this RB. Okay, so contactor coil is connected between the two phase of the supply line, that is R and B. See. Okay. This is overload actually. Okay. So this is actually like this. Yeah. Okay. Now power is connected here, power is coming here. So contactor coil will be energized. Okay. So now actually this is the wiring diagram. When the start button is pressed, this is the start button. This is start button. The remote start. This is remote stop. So this is start when pressed. Current will flow through one phase to the control circuit and the contactor coil to the other phase. Okay. So this will be like this. Okay. So this start. Okay. Overload relay. This will be like this. This is like this. Okay, okay. Yeah, it is connected MGCB fuse overload case circuit breaker. Okay, so actually we are finding that when the start button is pressed, current will flow to one phase to the control circuit and the contactor coil to the other phase, and this current energizes the contactor coil, which makes the close the contacts. Thereby, three-phase supply is connected to the motor. So when it is energized, so this plunger will say close all this terminal of the motor as a result. Okay, so this is actually hold on contact. Basically, when it is say energized, so all these terminals will be closed, and the motor will be getting supply. And if it stops, so this holding contact will close, and as a result, so after say when this push button is released, so the current will flow continue to contact to this hold on contact. Okay, so actually this the three-phase supply is connected to motor, and the start button is a push button. When it is released, the control circuit still maintains the supply to the hold on contact, as I told you. So if the stop button is pressed or overload relay coil operates, anyway, the current part to the contactor coil will break, and hence the contactor contacts drops out, and thus breaking the supply of the motor. And once the power supply is interrupted, again the supply to the motor is established after by pressing the start button. So just by either say this pressing this remote this stop push button, or in any case if this overload is being occurred, so in that case this will be a current path will be break to the main motor, that is supply will be broken, and as a result the motor will come in a stop position. Okay, so the thermal overload protection relays basically operates depending on the heating effect of the load current. So when the load current hits the thermal coils, the bimetallic strip inside of it expands such that it strips out the spring-loaded contact in the control circuit, and the speed at which the relay operates is decided by the current adjustment. And typically, it will be 4 to 5 times the rated motor current. So dual starter can be operated remotely for remote control switching or motor from any number of desired places. That is shown here. This is the remote start and remote stop switch, basically the same. Okay. See, and dual starter for remote control switching on should remember that all the remote on push buttons must be connected in parallel to the on push button of the starter, whereas all remote push buttons must be connected in series with the off push button. See here, this is connected in series and this is connected in parallel. Okay, so that is very you must have to clear it, or otherwise there will be a problem. Okay, so so connect the remote on and off switches as that is shown here in by this dotted line. Okay, so for remote control operation it is shown in the dotted line. So what are the it is clear that it is the operation. So that is this is basically the contactor coil which is connected across the two say supply line R and B here we are seeing. So when this MCB is closed, this coil will be say by pressing this start push button. So coil will be energized and the plunger it will be this plunger will attract will due to magnetic pole attractions. This contact will be closed and the motor will get supply through this overload which is in series with this. So whenever this start person is released, this hold on coil contact will say maintain the supply to the line, say motor terminals, so that is stator's terminal. And when this remote stop will is pressed, say supply line will break and the motor will come in a stop positions, or otherwise if there is overload or this overload bimetallic strip will be got expanded due to heat, and as a result this path will be open and the supply will be say off to the starter terminals, and as a result motor will come in stop positions. So that's all in a nutshell the operations of dual starter. Now what is the advantages and disadvantages of the dual starter? So dual starter is there are very so many advantages. It provides high starting torque, simple to use and most economical. Control circuitry is simple to establish and to troubleshoot, and easy to find fault and make necessary connections, and more compact in size and thus occupies less space. And disadvantages, of course, there are some disadvantages. So first disadvantage is high starting current, typically in the range of 6 to 8 times the full load current is flowing through this starter. So the induced current of a large motor may cause big voltage dip or drop in electrical supply system, which will affect other electrical appliances connected to it. And the unnecessary high starting torque required by the load may cause increasing mechanical stresses on motor and mechanical parts as well as the loads. So it is not feasible for high rating motors, typically above 10 kilowatt. So within the 10 kilowatt we can use this dual starter. Basically, since it is a very say high range of 6 to 8 times of the full load current is required for high. So to start the motor, so it is require a very high starting current, and in this induced current of less motor may cause a big voltage dip or drop in electrical supply system, and which will affect other electrical appliances connected to it. But other than this disadvantages, if we use this dual starter within say for the 10 kilowatt within 10 kilowatt ratings of motors, so it is a very, it provides high starting torque, simple to use, and most economical. Control circuitry is simple to establish and troubleshoot. easy to find fault and make necessary connections. So more compact in size and thus occupies less space. So with this, we'll close our discussions of